In this video, we're going to be talking about taking derivatives using the power rule. And I'm going to be honest, this might be a top 5 discovery of all time, alongside the JBL speaker and the air fryer. It's that good. But what actually is it? Let's say you wanted to take the derivative of x squared. Normally, you would have to go through the limit definition. You would plug in x squared, you would get x plus h squared minus x squared over h. You would have to expand, cancel things out, factor out an h, and then you would have to evaluate the limit, and you would get 2x. Now, you should know how to do this. If you don't know how to do this, I don't recommend watching this video, so you should probably go back to my other video, Intro to Derivatives. But the problem with this is that it takes too long. And I don't know about you, I don't want to have to go through 10 steps to get this answer. So let's use the power rule. And the power rule is really, really simple. If we want to take the derivative of our variable x to some power, where n is any real number, it's simply just equal to if we bring down that same power and multiply it, and then we subtract 1 off the power. So we get n times x to the n minus 1. Now, if you're still confused, let's go through an example. Let's differentiate x squared, again, but this time using the rule. So our first step is we want to bring down the power, so it's 2 times x squared. And then we want to minus 1 off the power. And what we're left with is simply 2x. And we get the same answer, except we do it 5 million times faster. But this is probably the simplest example I can give. So let's go through some more complicated examples. Let's differentiate our function f of x is equal to x to the 4th. So we're asked to differentiate f of x is equal to x to the 4th. And let's use our same rule right here. So the derivative, let's use this notation, df over dx is going to equal, we bring down the power and then minus 1 off the power. So it's going to be equal 4 times x to the 4 minus 1, which is just going to be equal to 4x cubed. And that's our final answer. Simple. For our next example, let's differentiate f of x is equal to 5x to the 3 minus 2x. We have f of x equal to 5x cubed minus 2x. And here we have two terms. But if you remember limit properties, the limit of two terms is just equal to the limit of the first term minus the limit of the second term. And while we're using the power rule, essentially we are still taking the derivative using limits, but we're just doing it quicker. So we can just differentiate these separately. So f prime of x, okay, is going to equal the derivative of 5x cubed minus the derivative of 2x. And so let's do this separately. The derivative of 5x cubed is equal to, so remember, let's bring down the power. So it's 3 times 5, and then we minus 1 off the power. So it's 3 minus 1. And this is just equal to 15 times x squared. The derivative of 2x is going to be equal, well, we have a power of 1 on the x. So if we bring it down, it's just 1 times 2. And then we minus 1 off the power. So 1 minus 1 is 0, so it's x to the 0. So we're left with 2 times x to the 0, and x to the 0 is just equal to 1. So we're left with 2. And so if we bring this together, f prime of x which remember is just the derivative, but a different notation, is equal to 15x squared minus 2. And this is our final answer. Now, let's differentiate some negative powers. Let's differentiate x to the negative 2 plus 4x. So here we now have negative exponents. And it may look different, but it's just the same thing. So again, let's differentiate each term separately. So let's take the derivative of x to the negative 2. So if we bring the power down, it's going to be minus 2 times x to the, and then we minus 1 off the power, minus 2 minus 1. And so this is going to be negative 2 times x to the negative 3. So now let's take the derivative of the second term. So the derivative of 4x, and I'm going to do this one faster if you remember from last time, it's simply just equal to 4. And so if we bring it all together, we have f prime of x, which again is just the derivative, is equal to negative 2 times x to the negative 3 plus 4. Now, you can leave this as the final answer, and that's perfectly fine. But if you want to simplify it, we can turn our negative exponent into a positive exponent by reciprocating the exponent. So it's just going to be equal to negative 2 over x cubed and then plus 4. And we have f prime of x. And again, this is our final answer. And this is also an acceptable final answer, either or. Now, let's differentiate 3 over x squared plus the square root of x. So in this example, we have a rational function plus a square root function, and we're asked to take the derivative. Now, it looks hard, but it's the same thing as we've been doing for the other 3 examples. So again, let's take the derivative of each term separately. So the derivative of 3 over x squared. So when we have a rational function, it's a good idea to turn it into a negative exponent, so it's easier to apply the rule. So if we want x squared to be a negative exponent, it's simply going to be 3 times x to the negative 2. Okay? And so this will make it a lot easier to differentiate. So now we can bring the power down, so it's negative 2 times 3 times x. Negative 2 minus 1 is going to be negative 3. So we're going to have negative 6 times x to the negative 3. And that's our first derivative. So now we want to take the derivative of the square root of x. Now, the square root of x is really just x to the 1/2. And so now we can apply our rule. So if we have x to the 1/2, let's bring it down. So it's going to be 1/2 times, and then we minus 1 off the power. 1/2 minus 1. 1/2 times x to the negative 1/2. 0.5 minus 1 is negative 0.5, so negative 1/2. And so if we take the full derivative, we have f prime of x is equal to negative 6 x to the negative 3 plus 1/2 x to the negative 1/2. And this is a perfectly acceptable answer, but if your teacher doesn't like it and they want you to simplify, we can do that simply. So it'll be f prime of x is equal to, again, we turn our negative exponents into positive exponents. So it's negative 6 over x cubed plus, same thing here, it's going to be 1 over 2 times the square root of x. And again, the square root of x is just 1/2, but we turned it back into the square root. And this will be our final answer. Definitely much faster than using the limit definition. And for our final example, let's differentiate f of x is equal to 7. So here's our final example, and we just simply have f of x is equal to 7. And if we use it with the power rule, now you don't really need the power rule. Okay, you can do it just by pure logic. Okay, let's use the power rule. we have no x here. So what we really have, is f of x is equal to 7 times x to the 0, because we have no x's. X to the 0 is just equal to 1. So if we were to take the derivative, okay, using our rule, we would bring down the 0 and then minus 1. That's what we would do. So it would be 0 times 7 of x to the negative 1. And we don't really have to worry about any of this because we have 0 times whatever, and it's simply just equal to 0. And you can also just see this makes sense. If we have the graph of y equals 7, it is simply just a straight line. Now remember, the derivative is finding the slope of the tangent line. And if we have a straight line, our slope, okay, our rise over run, is just equal to 0. So you don't even really need the power rule. You can just know that since we have a straight line, it's simply equal to 0. And this doesn't just go for 7. This goes for any constant. So the general rule, the derivative of some constant n is simply just equal to 0. So our final answer is 0. And that will be it for this video. If you found this video helpful, make sure to like and subscribe, and I will be posting more videos on derivatives soon.